This is the stats lesson for Block B on Friday the 20th of January. We got as far as finding E of x, or the expected value or mean from a table. So we did the first parts, A, 1A, 1B and 2, the first part just E of x. And then what we needed to do was just work out the expectation for x squared. So you can see here, if you can check your answers, because I asked you to finish off these ones here where we have the x squared. It'd be quite useful if you just actually drew another row on your table and you put your x squared values in there, and then you can work it out from that, and you've got your formulas from before. So what I'd like you to do, just to have a bit of a refresh really, can you now do question 3, where it's given you a probability function, and the probability is 1 over x for x equals 2, 3 and 6, and it's 0 for all other values. So construct a table given the probability distribution of x, and work out E of x and E of x squared, and state with the reason whether or not these statements are equal. So if you pause the video now and give yourself about 5 minutes to do that, and then I'll just to refresh on last lesson, and I'll put the answer beside it. So the solution we're looking for question 3, we've got the probability distribution, so it's just 1 over x, whatever value x is, and I've left it as fractions. So we should always have this as exact values where possible. You can have exact decimals, but it's better a sixth and a third cannot be expressed exactly. Part B, working out E of x is 3 and E of x squared is 1. Is E of x all squared equal to E of x squared? Well, they're not, because as you can see, the two calculations, if we take E of x and square it, we get 9, and E of x squared is equal to 1, so they're not actually equal to each other. Right, let's move on to the next part then. We're going to find the variance of a random variable, and we can use this as we've seen it before. It's the variance equation, and it's the mean. Remember, E of x can also be called the mean. So it's, as we've done before, it's the mean of the squares minus the square of the means. And that's what we've done with data before, continuous and discrete values. So looking at this example then, and the equation we're going to use. 2 fair cubical dice are thrown, one is red and one is blue. The random variable m represents the score on the die, red die, minus the score on the blue die. Find the probability distribution of m. So as you can see below, what we've got is a sample space diagram. And what I'd like us to do is, according to the rule that we've got here, we want to complete the table. So the red one is at the blue one's at the top, and the red one's down the side. So one minus the other. So 1 minus 1 is 0. 1 minus 2 is minus 1. 1 minus 3 is minus 2, and so on. And let's fill up the rest of the table. What do we have? 2 minus 1 is 1, 3 minus 1 is 2, 4 minus 1 is 3, 5 minus 1 is 4, and 6 minus 1 is 5. So down the centre, as you can see, we're going to get 0. And along here, there's a little bit of symmetry going on. And these are all the possible outcomes that we get when we throw the two die together. So altogether in that sample space diagram there are 36 outcomes. So our probabilities are going to be out of 36. So that's the best way to actually look at it. Right, find the probability distribution of M. Right, the possible values we've got, when we see, it runs from the value of -5 right the way up to 5. So we need a table that covers all of those possible outcomes. So let's pop a table underneath and fill that out. So we can see there it runs from -5 all the way up to 5. So we want the probabilities for each of those. So that's the case of looking at the table and seeing how many outcomes that we've got. So -5 only happens once, so it's 1 out of 36. -4 happens 2 times, 3 times, 4 times. -1 happens 5 times, and I'm leaving it all in 36 just in case. I just want to actually add these all up, and I should get a probability adding up to 1 of the total event. So again, it's going down as 36. And if we add up all the probabilities, just as a little check, we should actually get 1 in that table. Okay, so that was part A. Part B was asking for write down E of M. Well, as you know, E of M is the expectation. So the expectation of M is equal to the sum of all the M's times the probability of them. And if we write that out in full, that's -5 times 1 over 36 plus -4 times 2 out of 36 plus -3 times 3 out of 36 plus, and that goes all the way up to the end, which is 3 times 3 over 36 plus 4 times 2 over 36 plus 5 times 1 over 36. Now you can't actually pop that into your calculator and see what you get, but I can see straight away that the answer for that is actually going to be equal to 0. If you look at what we have at the beginning, we've got -5 times 1 over 36, and we've got a plus, so those two cancel out, those two cancel out, and so on, and everything in between also cancels out, so we get a 0. And that's also quite apparent from the table. If you look at the diagonal going down there, you can see that the table is symmetrical, and by symmetry the expected value that you would get would be that middle value. So you can, rather than working things out, you can actually look at the distribution and say by symmetry it is actually the expected value is 0 from this one. So by symmetry, A of M is actually equal to 0. So just bear that in mind when you do some of the calculations. Right, this is the new part, and the new part asks for the variance. So what we need is the variance of, this part C, the variance of x is equal to the variance of the mean of the squares minus the square of the means. Right, the x squared, the E of x squared, and in this case it's actually m, isn't it? E of m squared we're going to have to do is equal to the sum of the m squared times the probability. So really on the table we could put another row that says m squared and have 25, 16 and so on. And when we work that out, it's going to be 25 times 1 over 36. And that's actually going to happen 2 times, isn't it? It's going to happen for -5 and +5. Then we're going to have 16 times 2 over 36. And again, that's happening 2 times. And so on. And then if we work out e of x, which we did before, so that was e of m was equal to 0, so e of m is going to be all squared, is still going to be 0. So the variance of m, once you do all the calculations, if you pop that in, you get 105 all over 18. And that simplifies to 35 over 6, which is approximately equal to 5.83 recurring. So just take a moment. You may want to fill in a few more steps here. I've just done a couple of them. You can fill out the whole table, and it's just to get used to doing this part again, the variance of m in this case, using the formula. So what I would like you to do in this exercise is exercise 8D, and that's question 1, 2C and 7. And what I'd like you to do is stop the video now and take about 5-10 minutes to get through these questions. I'll pop the answers on the video, and then you can start the video up again and check your answers. Okay, welcome back. Exercise 8D, question 1. Working out the mean or the expected value. We multiply the outcome with the probability and we get 1 for this one. Then we do all the x squareds and we can work out e of x squared, which helps us with the variance. There's your formula. So always write the formula down and then calculate it. Question 2, same idea, just some number crunching going on. So we get the expected value or the mean to be -1/2. Then the variance are worked out to be 9 over 4. Question 7 was exam type standard, where you have got unknowns involved and you've got 2 unknowns, so you're expecting to be able to form 2 equations, one from all the probabilities add up to 1, and the other one is being able to work out what the variance is, because you were given that in the question is 0.75. So if you take equation 1 and you sub it into equation 2, you should get these values here. Now, in other words, that could be as a fraction and 3/8, and that one there is a quarter. So either decimals that are exact or fractions that are exact as well. That's the absolute bare minimum to do on exercise 8D. There are other questions in there that you could try just for some extra practice. We'll now move on to the next section, which is on page 21, and it's 8.9. We're just going to be extending the idea of expected value and the variance to deal with the function, if we get a function of x. So if it's not just the data itself, if we're given it in terms of, say, 3 e of x or e of x plus 3, something like that. And that'll make a bit more sense once we do this example. So the bits that are not given to you, and these are very popular in an exam situation because it's requiring you to remember a rule. So the general rule that we want to remember is this one here. So if we have e of x, it relates to e of ax plus b. We take the a out, we multiply e of x by whatever the number a is, and then we add on b. In exactly the same way, there is a formula for the variance, but with the variance we forget about the b, and you've got to memorise these. They are not given. So two equations there, and the second one you can see if we've got the variance of x and a times x plus b happens to be related to this one, then what we do is we take the a out and we square it and we ignore the b. That's what happens. So what it's saying here is the variance is a measure of spread really relative to the mean, so adding a constant value to all of the values of x will not affect the measure of the spread. Hence b does not change. That's a bit like the coding that we've done before, where we can just ignore anything that we add on. And the a squared is understandable because if you remember, if we've got the variance of x, it's the mean of the squares minus the square of the means. So if each value of x is multiplied by the value of a, then the variance altogether is going to be multiplied by a squared. So that's the two things that we have to remember for this next section. And as I say, this does come up in the exam because you have to memorise it and you have to apply it as well. So looking at example 13. A discrete random variable, so it will always say that in the question, so you know that you're working with countable pieces of data. We've got this probability distribution. So write down the probability distribution for y, where y is equal to 2x plus 1. Right, we can apply the rule. First of all, we can find out what e of x is, so the expected value of x, which will be 1 times 12 over 25 plus 2 times 6 over 25 plus 3 times 4 over 25, and the final one 4 times 3 over 25. So what we've got there are 4 lots of 12 over 25. Which is equal to 48 over 25. So that is our expected value of x. So the relationship we have is for b, I'm forgetting about part A, by the way. I'm just going to do part B. So find this part. That's not part, this is part B. So I'm just going to say e of y. We don't actually have to do that first part to work it out. We can use the rule and we can say that e of y is equal to e of, the relationship is 2x plus 1. So what does that say? From a rule from before, all we do is take 2 times e of x and we add on 1. So that's what a rule said from before, if you look above on the page. So we have 2 times 48 over 25 and then add 1 on to it. So we have our calculators here, so that's 96 over 25 plus 25 over 25. Altogether that is 121 over 25, which is 4.84. Can leave it in either form, it's absolutely fine. So it's just that second bit that I wanted to do, given that we had that relationship there, so just fed that into there. That's all I'm interested in, applying that rule. Example 14 gives us a better idea of applying the rule completely, so that's on this page, and as you can see we've got e of 3x and so on. We've been given the information at the question at the beginning here, so it should be fairly straightforward just to apply all the rules. So in part A then, e of 3x is simply 3 times e of x. We've been given that in the question, so that's 3 times 4, so that should be equal to 12. Taking on the next part, we've got e of x minus 2, so that is just going to be e of x and then subtract 2 from it. So e of x is 4, take away 2, our expected value of that distribution is 2. Looking at part C, this time we want the variance of 3x. Well, we just want to square the 3 and take the variance of x. That was our rule from over the page, and you've got to recall that. So that will be 9 times the variance, which is 3, so that's going to give me 27. For part D, watch out for trick questions like this. It's the variance of x minus 2. And by subtracting a number from the variance, it doesn't actually change it, so it's just the same as the variance of the x. So that is equal to 3. And then on the last one, we want e of x squared. And if you think about the formula that we have, the variance of x is equal to the mean of the squares minus the square of the means. So if we rearrange this to make e of x squared the subject, that means e of x squared is equal to the variance of x plus e of x all squared. So all I've done is I've left the e of x squared there and I've taken this over to the other side, and that's just a little bit of manipulation of the formula that we know already. So that's going to be 3 plus 4 squared, which is equal to 19. Moving on to the next example, just so that we're familiar with all the formulae from the beginning here. We've got 2 fair 10p coins and they are tossed. The random variable x represents the total value of the coins that lands heads up. Find e of x and the variance. Okay, so the total value, if they're flipped twice, then we could have heads up. So 2 heads up would have a value of 0. We could have 1 head up and a tail, which give us 10 showing, so that'd be 1 value, and 20 pence would be when you've got 2 tens, 2 heads landing up. Okay, so what does that mean in terms of a table? For part A, the distribution of x becomes this little table where we have x is 2 tails gives us 0 pence, 1 head gives us 10 pence, and 2 heads landing gives us 20 pence. So that's the probability of these happening. So that would be a quarter. We've done that before, but thinking about your sample space. That would be a half, and 2 heads would be a quarter. Now if we want to find e of x, I don't particularly have to work that out. I think you can see here by symmetry that we've got, it lands right in the middle here. So by symmetry it should actually be 10. But if we want to just make sure, it's going to be 0 times a quarter plus 10 times a half plus 20 times a quarter. So that would give us 0 plus 5 plus 5, which is 10. So if you need to work it out, you can't see it by symmetry, then the calculation's still going to work. We want the variance here, which is e of x squared, so the mean of the squared minus the square of the mean, and if we work that out altogether, that's going to be 50. Okay, I'll let you put the numbers in there, but you can accept from me that that's going to be 50. You have to really put another column on the table there for x squared. Right, moving on to the next part then. The random variables s and t are defined as follows. S is equal to x minus 10 and t is equal to a half of x minus 5. So we've got a relationship between s and the original variable x, and we've got a relationship between t and the original x as well. So when we work these out, we do it in relationship to the expectation of x. So in part B, e of s is going to be the same as e of x minus 10, which is just e of x minus 10. So if we pop that in there, that will just be 10 minus 10, which is 0. If we work out e of t, it's the same as the expected value of a half x minus 5. So that's going to be a half of e of x minus 5. So that equals a half times 10 minus 5, which is also equal to 0. So therefore, we've shown e of s does actually equal e of t. We want to use the same rules as before, and we're working out the variance for s and t. And if we do that, we can still use the relationship between x. So we have the variance of s is equal to the variance of x minus 10, and we've subtracted there, which is just the variance of x, so that's just using the rule, so that is equal to 50. And the variance of t is equal to the variance of a half x minus 5. So that's going to be equal to a half squared the variance of x. So that's going to be equal to a quarter times 50, which is equal to 12.5. Part D. Susan and Thomas play a game using two 10p coins. The coins are tossed and Susan records her score using the random variable s. So she uses this distribution here, s and s for Susan. And Thomas uses the random variable t, so Thomas is et and variance t. After a large number of tosses, they compare the scores. Comment on any likely differences or similarities. Well, the total scores should both approximately equal 0. So we're looking at the expectation, so they're both going to come out with nothing if they're playing that game. And Susan's score should be more varied than Thomas's because the variance is 50. It's a large number, so that means the spread is bigger, and Thomas's is only 12.5. So let's put that into an explanation. So the total scores should both be approximately 0, and Susan's scores should be more varied than Thomas's. Okay, last example, and just making sure that you know how to manipulate the formula here. And we've got, on the first one, the random variable y has a mean of 3 and a variance of 8. How do we work that out? Okay, for the first part then, for A, E of 12 minus 3y. I would quite like to write that a little bit differently. If we put it in the form that we knew from before, minus 3y plus 12. So that says it's minus 3 times e of y plus 12. So we've got a mean of 3, so it's minus 3 times 3 plus 12 minus 9 plus 12 gives us a mean of 3. For part B, the variance of minus 3y plus 12. We can ignore the plus 12, it has no effect on the variance, but the minus 3 does. So it's minus 3 squared, and it's the variance of y. So that's going to be 9 times the variance, which is 8, so that's the variance of 72. Okay, what I'd like you to do then is exercise 8E, and if you could do the following questions. Question 1, straightforward. Question 3 and question 5. The other question that I'd like you to do is question 8. So if you stop the video just now, do those questions. Again, I'll give you the answer, so give yourself a good 10 minutes to do those. I'll give you the answers and then you can check yours against them. Okay, once you've done those questions, if you have a look at the answers here, and if you notice on question 8, the answers are given as exact as possible if you can. Okay, right, we're now on to our last part, and we should be finished this chapter today. And what I'd like us to do is move on to section 8.10. We want no, it's 8.11 rather, miss out that one. 8.11. Using a discrete uniform distribution as a model for the probability distribution of the outcomes of certain experiments. So the probability distribution for the score on a single roll of die, as we know that. Now, this is called, and you notice the key words there, this is called discrete uniform. There's your new word, uniform. And why is it uniform? It's because all the probabilities are the same. If it's a fair die, if it's a fair coin, this equal chance of each of these outcomes is going to be the same. It's called discrete because we can actually count the number of values that we've got, and because it's uniform because the probabilities are all the same. So that's key. So the values are discrete. So conditions for a discrete uniform, so not random but discrete uniform distribution, that the variable is actually random. X is defined over a set of n distinct values, so that means it goes from, probability is from 1 to 6 for this die here. And in many cases, X is defined over a set starting at 1 going to n, so that's all your natural numbers. In such cases, the mean and the variance are given as these formulae. And these, can you check in the formula booklet, are they actually given to you? You can see, have a look in the formula booklet. We don't actually have to prove these ones or know them for the examination, but you might find them useful in answering some of the questions. So it's only if it is a discrete uniform distribution. We can't use it in what we've been doing before, and these questions are really, really straightforward. Right, let's move on to the example at the bottom then. Digits are selected at random from a table of random numbers. Find the mean and standard deviation of a single digit. Find the probability that a particular digit lies within one standard deviation of the mean. Okay, how do we go about this then? Well, digits are single numbers. In this case, the digits will be the numbers from 0 to 9 inclusive. Let R represent this random variable having a discrete uniform distribution. So there's your key statement there, discrete uniform distribution over the set from 0 to 9. So the relationship, let the x represent a random variable having a discrete uniform distribution over this set here. So how do we represent x or r in terms of x? And the simple relationship is, to get r, you just take 1 away from x. So by introducing this random variable x, you can use the standard formula for x with n equals 10. So let's have a go at it. So all we're doing is using those formulae from above. So the expected value of a single digit r is the same as e of x minus 1, which is e of x, take away the 1, which is n plus 1 over 2 minus 1, which is equal to 10 plus 1 over 2 minus 1, which is equal to 4.5. And the variance of r is equal to the variance of x minus 1. The minus 1 makes no difference, so it's equal to the variance of x. And if we use the formula from before, n plus 1 over n minus 1 all over 12, then that's equal to 11 times 9 divided by 12, and that's equal to 8.25. And as you know, the standard deviation is sigma, and that's equal to the square root of the variance. We've done that from before, and if we give that to 3 significant figures, it's 2.87. Now, using the value of sigma in A, the required probability, so find the probability that a particular digit lies within one standard deviation of the mean. Right, so one standard deviation, that is one standard deviation there. So what we're actually saying here, and this will make a little bit more sense when we actually go on to do the normal distribution. You can understand what a standard deviation is. So it's actually the probability, standard deviation from the mean. So that's 4.5 minus 2.87. So that's the lower part. And that means that r has to be in that, or 4.5, add a standard deviation. So within one standard deviation means one below. So this is the standard deviation below, and this is standard deviation above. That means it's the probability of 1.63 and so on. R lies in between 7.37 and so on. We can't have decimals for discrete values, so we'll take that to 2 and we'll take that to 7. So the probability of 2 is 6 out of 10, and the probability reduces to 3/5. Okay, I think that for this last part here, this really doesn't come up in the exam very often. And what I'm more interested in is the mixed exercise 8G. So the questions that I would like you to do, I've changed my mind. I would like you to do on exercise 8F. I would like you to do question 1 and 7. And then what I'd like you also to do is for homework on file paper, mixed exercise 8G, questions 1, 2, 4, 9 and 10 for Friday the 27th of January. So that's a week today. And the two questions that I want you to do just now are 1 and 7. So 1 and 7. And then take note of the other questions there. I will pause this again and I'll give you about another 5 minutes or so to do question 1 and 7. I'll write the solutions down. You can mark your work. If you do happen to get all of this finished today, then that's fantastic, well done. If you need some more practice, then go back into the questions from the previous exercise. And then if you need some extra practice, exam practice, you find over on the table at the side beside the door, there are trays of bronze, silver and gold exam papers. Can you please take bronze 1, statistics 1, and you should be able to do everything on the paper except the normal distribution. So that's stats 1, bronze 1 paper, and that's on the side over where the very large pink notice boards are. So I'll pause the video now. I'll write the answers for questions 1 and 7, and then you can check your answers too. Right, the answers to 8F, as you can see here, can you just check what you've got for your answers for question 1 and question 7. And then just as a reminder, for next Friday, so that's Friday the 20th of January, I would like mixed exercise 8G, and it's the questions 1, 2, 4, 9 and 10, and that's on file paper to be handed in the lesson. Thank you. And as I say, if you manage to get that finished, then the stats 1, bronze 1 paper over on the table at the side beside the pink notice boards. Help yourself to one of those and really make a start to your revision. Thank you. Oh, the other thing is, please try keeping up with the BRICS website. I notice some of you have tried it, which is great, and it looks quite useful. So it's worth a visit just to help you. Thank you. That should be Friday the 27th, because it's Friday the 20th today. Thank you. Exercise 8G.